Now let's just talk about the presentation of a data. So for an instance, if I'm just taking an example of the marks which is obtained by the 10 students in a mathematics test as nothing but given as this. Now you can see over here the data is actually very small, and let us suppose if I'm just talking about this particular data. So this data in this form is called as nothing but a raw data, and if I'm just arranging this data in an ascending or a descending order, then I can conclude a lot of things from that. So for an instance, if I'm just arranging this particular raw data into an ascending order, so this is nothing but the data which is of this form. As you can see, I have actually arranged them in an ascending order, so I can able to find out a very important thing which is all related with this particular data, which is nothing but called as the range of the data. You can see over here that we do have the highest marks which are obtained by a student in the mathematics test, and we do have the lowest mark which is obtained by a student in the mathematics test. So using those two marks, I can able to find out the range, because range of the data is actually the difference in between the highest and the lowest value in the data. So the range of this data is nothing but 95. 95 you can see is nothing but the highest value in the data, and 25 is nothing but the lowest value in the data. So the range is nothing but 95 minus 25, which is nothing but is equal to 70. But let us suppose rather than this small data, we have a large number of data. So it is quite a tedious task for us to arrange the data in an ascending or a descending order. So for that kind of data, how we can deal with it? Let's just see. Let us suppose if I'm just taking another example, and we have the marks which is obtained out of 100 by the 30 students of the class 9th of a school, and these are the marks that we have. Now you can see over here that this data is definitely much larger than the previous one. So how we can deal with such kind of a data? For this data, we'll deal with the definite kind of a word, means we use a frequency over here to represent this data. What is a frequency? The frequency means the number of the students who have obtained a certain number of the marks is called as the frequency of those marks. What does it mean? Let us suppose if I'm just talking about this data. Now in this data you can see we have a student who actually obtained 10 out of 100 marks in a test. So 10 is actually coming only one time. So what is the frequency of 10? 10 is coming only one time, so the frequency of 10 is nothing but 1. So if I'm just talking about 20, so you can see in this particular data 20 is actually coming only one times. You can see all by yourself that 20 is actually coming only one times. So what is the frequency of 20? 20 is coming one time, so the frequency of 20 is nothing but 1. And in the similar manner, if I'm just talking about 36, now 36 is coming how many times? Let's just see, this is 1, further let's just move on, this is 2, this is 3. So the frequency of 36 is nothing but 3. Why so? Because 36 is coming 3 times in this particular data. So using frequency, now we can arrange this data in another way, just different from that of the previous one. So let's just see how we can arrange this in a particular kind of a table. So let us suppose if I'm just writing all the marks over here that we have in the collection of the data. So we have 10, 20, 36, 40, 50, 56, 60, 70, 72, 80, 88, 92, 95. And with respect to the marks, I'm just writing up all the frequencies. Frequency means the number of the student, those who have the 10 marks, those who have the 20, those who have the 36, and so goes on. So as you can see over here, if we were talking about the number of the student, those who have only 10 marks, that was nothing but only 1. So the frequency of 10 is nothing but 1, and frequency of 20 is nothing but 1, frequency of 36 is nothing but 3, frequency of 40 is 4, and so goes on. So this is the way we can represent, or we can represent any particular kind of a data in which we can use a word frequency, means we can use a topic or we can say we can use frequency with which we can form certain kind of a table, and such kind of a table is actually called as the ungrouped frequency distribution table, or many a times we also call it as a frequency distribution table. So always remember, whenever we have such kind of a data, we can represent the data with the help of the ungrouped frequency distribution table, which is nothing but of this form. Now let us suppose if I'm just taking a bit more data rather than the data which is given in this example. I'm taking a lot more bigger data than this. So how we can present that kind of a data? So let us suppose if I'm just taking another kind of an example, and we have the 100 plants which were planted in the 100 schools during one Mahotsav. After 1 month, the number of the plants that survived were recorded as this. Now you can see over here the data is much more bigger than the previous two examples. Now how we can arrange such kind of a data? So for this or we can say for the presentation of such kind of a data, we use the intervals. We use intervals. So what are those? Let us suppose if I'm just talking about this kind of a data. So as you can see over here, if I'm just looking out for the minimum value over here, the minimum value, let us suppose if I'm just starting with the minimum value, as you can see we have 28 is the minimum value in the very first row, and further we can see that where is a value which is lesser than 28. Let's just look out for that. As you can see over here in this row or in this row, we do not have any value which is less than 28. Yes, we have this value which is nothing but 23. So if we have the minimum value as 23 in this particular data, so we'll start the intervals with 20. So what is that? Let us suppose if I'm just talking about these representations, so these are actually called as the class intervals, in which I'm starting with 20, because we know that the minimum data which is given to us in the previous example was 23. So I'm just starting with 20 and I'm going till 99 as per looking at the highest value which is required in that data. I'm just taking the last number or the last digit over here as nothing but 99. So my in my data all the values are lesser than 99. That's why I'm taking 99 over here, which is nothing but my last value. So keeping in mind always the data which is always given to us, we always have to start the intervals from the lower, as you can see, from the lower digit we have to start, and we have to go till that particular digit which is the highest one among all the data which is already given to us. Now further you can see that I have just taken the intervals as 20 to 29, 30 to 39, 40 to 49. So these are actually called as, these grouping of classes we can say is called as the classes or the class intervals. So whenever we have such kind of a bigger data, so we always have to group that kind of data into the form of the classes, which are called as the classes or the class interval. And further, there is one more important thing which is related with this class interval, which is actually called as the class size or the width. So what is the class size or their width? As you can see over here, if I'm just talking about all these classes from 20 to 29, from 30 to 39, from 40 to 49, the size of all the intervals is nothing but 10. So this is nothing but called as the class size or its width. So their size is called as the class size or the width. Moreover, the least number is called as the lower class limit and the greater number is called as the upper class limit. Now if I'm just talking about all these intervals, so let us suppose if I'm talking about the very first, so 20 to 29 is my first class interval. So 20 is nothing but the least number over here, so this is called as the lower class limit. 29 is called as the upper class limit. Similarly, 30 is called as the lower class limit, 39 is called as the upper class limit. So 40 is the lower class limit, 49 is the upper class limit. So always remember, in the class intervals we have two type of the limits, means a lower limit and an upper limit. So lower limit is the least number and the upper limit is the greater number in these intervals. Now let's just form a table which is all related with it. Now let us suppose we are using this presentation of data, or we are representing this data into the form of a telemark. We already are aware about that, how we can represent any particular data in the telemark. So let's just see how we can represent. So first of all, I'm just taking all these intervals over here from 20 to 29, from 30 to 39, from 40 to 49. I'm just going till 99, and for this I am just representing a table, or I'm using a table which is nothing but a table of tally marks. So if I'm just go with the data again, or I'll just see the data again, so I can see that from 20 to 29 we actually have the three students which do have a marks that are lying in between the intervals 20 to 29. So we will write the tally marks as, let us suppose if I'm just writing up the tally marks, so the tally marks can be written as, we only have the three students which do have a marks that are lying in between 20 to 29, so we'll write the tally marks as 1, 2, 3, because only three students do have the marks that are lying from 20, not the marks, because this is the example of the number of the plants. So the number of the plants that we have is nothing but only 3, not the number of the students. We are not talking about the previous example, we are talking about the One Mahotsav's example. So in that we have only 3, means we have the number of the plants that survived was only 3, which is lying in between 20 to 29. And further, if I'm talking about 30 to 39, we have 14 elements which were actually lying in between 30 to 39. So let's just write them into the formation of a tally mark. So this is 1, 2, 3, 4. 1, 2, 3, 4 we have, and further we have this is 5, and further 6, 7, 8, 9 and 10, 11, 12, 13 and 14. So we have 14 elements that are actually lying, or 14 numbers that are actually lying in between the intervals 30 to 39. And in the similar manner, I'm just moving on further with 40 to 49. So if you just count the number of the elements or the figures that are lying in between 40 to 49, they were actually 12 in the previous data, 12 in the example. So I'm just writing up 12 over here. So how we can write the 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Now further, from 50 to 59, we have 8. We have 8 elements that are lying in between. So this is 1, 2, 3, 4, 5, 6, 7, 8. Further, from 60 to 69, we have 18. So I'm just writing up over here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Further, from 70 to 79, we have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And further, from 80 to 89, we have 22. We have 22 actually elements that are lying in between, 23 elements that are actually lying in between this. So let's just form 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 and 23. From 90 to 99, we have 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, with respect to these tally marks, I am just writing up the frequency. So this is the frequency table that I have. So the number of the schools is nothing but represented by the frequency. So this is 3, 14, 12, 8, 18, 10, 23, 12 and 100. So this is the way we can present or we can represent any particular kind of data using the tally marks and the frequency table as well. So such a type of the presentation of the data is called as the grouped frequency distribution table. Why it is called as grouped? Because we are forming up the groups of the data over here as the class intervals. So this is nothing but called as the grouped frequency distribution table. So this is nothing but another way to represent a data. Now, as we have seen in the previous example that the class intervals that we have formed was actually the non-overlapping one. Yes, they were actually the non-overlapping one because we have taken the intervals as 20 to 29, 30 to 39 and so goes on. So they are non-overlapping one. So there is no hard and fast rule that we always have to create the intervals that are non-overlapping one. We can create the intervals that are overlapping with each other, and we can also create the intervals which are shorter in size, because rather than starting it from 20 to 29, I can also start it with 22 to 29 as per my own convenience. So there is no hard and fast rule for such kind of things. So always remember, we can shorten the intervals, we can create the overlapping intervals as well. So that's why I'm just moving on further towards an example in which I am creating an overlapping intervals. So let us suppose if I'm just taking another example, I'm taking the example which involves consider the following frequency distribution table which gives us the weight of the 38 students of a class. So this is actually the representation, or this is the table which is actually given to us in the question. And as you can see in the intervals, we have 31 to 35, 36 to 40, 41 to 45. They are definitely a non-overlapping intervals. Now I am just forming them up into the overlapping one. So how we can do this? So let us suppose if I'm just starting with the two class intervals only. So I'm just taking the very first class interval which is 31 to 35, and I'm just taking the next class interval which is 36 to 40. So since if I'm just talking about the two intervals that we have 31 to 35 and 36 to 40, so first of all I'm just talking about the lower class limit of 36 to 40, which is definitely nothing but 36. And if I'm just talking about the upper class limit of 31 to 35, which is nothing but 35. So I'm just subtracting both of these, and if I'll just subtract or I'll just take the difference of both of these, so this should be nothing but is equal to 1. Now take the half of this difference, which is nothing but 1 by 2, which is 0.5. So in order to create the overlapping intervals, you always have to subtract, or you always have to do such kind of steps, and after that you have to subtract 0.5 from the lower limit of each class interval, and you have to add this 0.5 difference to the upper limit of each class interval. So what we are taking over here is nothing but, so the new class intervals formed from 31 to 35 is 31 minus 0.5 to 35 plus 0.5. So what I am doing up over here, I am just subtracting this difference that is 0.5, or this half the difference means 0.5 from the lower class limit means 31 minus 0.5, and I'm just adding this 0.5 to the upper class limit, and in the same way I'm just doing it with all the class intervals. So you can see over here the class interval which would be formed should be nothing but of the form 30.5 to 35.5, and the other class means if I'm just moving on further towards the second class, so this should be 36 minus 0.5 and 40 plus 0.5. So this will give rise to 35.5 to 40.5, and so goes on. So if I'm just talking about the interval, so you can see the intervals now would be of the new form, which is nothing but this, and you can see all by yourself that they are nothing but the overlapping class intervals, because we have 30.5 to 35.5, we have 35.5 to 40.5, means they are starting from in a continuous manner. They are the overlapping one, 35.5 to 40.5, 40.5 to 45.5, and so goes on. We are just going till 75.5. So if I'm just completing up this table, so this is nothing but a table in which we have taken the class intervals as the overlapping one. Moreover, there exists a special note which is related with it. So let us suppose if I'm just talking about a special note over here. So in the intervals, in the class interval 30.5 to 35.5, in the class interval, this, if we are taking the observation, 30.5, so it will be included in the interval 30.5 to 35.5. But if we are taking 35.5, then it will be considered in the interval 35.5 to 40.5. So this is a very special note which is all related with the interval. So always remember, whenever we are just talking about 30.5, if I'm just considering this one only, if I do have an observation which is a number that is 30.5, so 30.5 will be considered in this interval only. But if I'm just talking about 35.5, so this 35.5 would not consider in this interval. This would be considered in the interval which is 35.5 to 40.5. This will be considered in this interval only. And if I'm just talking about 40.5, so this 40.5 will be considered in the next interval which is nothing but 40.5 to 45.5. And again, if I'm just talking about 45.5, so this won't be considered in this particular interval. 45.5 would be considered in this particular interval. So this is a very special note which is related with this presentation of data. So always remember this note, that whenever we have such kind of an observation, so always remember that for this interval only this 30.5 number of observation or this observation should be considered only in this interval. The upper limit is always considered in the next class interval, that is nothing but 35.5. So this is nothing but a very special note which is all related with this presentation of data.